In this module, we will brief about another popular data structure known as stacks. In real life, we may encounter in many places stack type of structures. For example, consider that you have been to a party, buffet party, where you will find a stack of plates. All the people will be going one after another and will be taking the plate which is on the top only, and then they get their dinner served. Similarly, after finishing their dinner, they will be keeping all the plates at one point. There also, we will be leaving our plate on the top of the already available plates. We will not dare to remove a plate from the middle of the stack of plates, and also we will not be inserting or pushing our plate after finishing our dinner in between some stack of plates. We consider it is not attractive or it's not following the principles of buffet systems. Anyway, so here we are able to take an item from the top, and also we are going to push the plate on the top only. You may find in some other hotels a special structure. When a user takes out one plate, automatically next plate will come. There will be a spring-like mechanism as shown in the slide. Maybe this is one example which immediately sounds to me to give a feeling of what's meant by stack. So here we are putting a plate from on the top. At the same time, we will be removing plates from the top only. This type of operations are common in stacks. Even we can have stack of cups. We may insert a cup on the top. We may remove the cup from the top. We may have stack of received letters. The topmost letter is the one recently received one. The bottommost one is the one received long back. Consider the following slide. Here first A is pushed, then B is pushed, and then C is pushed. Thus, the objects A, B, C are in the stack. We can take out the topmost item, that is C, then B, then A. Thus, the stack becomes empty. Like this, we may be in a position to do some operations such as push and pop and this type of structures. In a nutshell, stacks are linear structures. Also, homogeneous objects can be maintained in the stack. All deletions and insertions can be done at one end only. That is normally called as top of the stack. Essentially, the most recently pushed object will be removed from the stack first. Thus, this is also called as last in, first out structure. In a nutshell, we have the following type of operations on the stack. Push operation. A new item or object can be pushed onto the stack at the top. Similarly, pop. A object which is on the top of the stack, that will be removed. However, there is one more operation known as peek or top of stack. So, there is a difference there between pop and this peek. Pop will remove the topmost object and returns the same. Whereas peek, it will not remove from the stack. However, it returns the topmost element on the stack. It's more like a peeking, sensing, but it's not going to be removed. So as time progresses, we'll be knowing the main difference between these two things. Similarly, if we go on pop, then there is a situation arises, there are no more elements in the stack to be popped. Such a condition is called as is empty. That is, this operation can be done on the stack. Similarly, if the stack is realized using arrays, usually stacks can be realized either using arrays or linked list. If we use array, there is language support array, and then realize the stack, as language support array will be having finite size, after some specified number of pushing operations, the array gets full. Thus, we may not be in a position to insert next item. Such a situation is called as stack full. So, we may be using some operation on the stack known as is full. These are the important operations on the stack type of objects known as pop, push, peek, is empty, is full. However, if we realize the stack using linked list, theoretically linked list can grow to any extent. Thus, there will not be is full situation in the linked list. We will be discussing more about this as time progresses. Now consider another example. Just to demonstrate the operations on the stack, we are having this example. So initially we consider the stack is empty. So at this junction, if we call is empty, then it will return true. Now we assume that a blue item is pushed. So thus top will be pointing to the blue item. After that, red item is pushed. Thus top will be pointing to red item. And then green item is pushed. Thus top will be pointing to green item. And then purple is pushed into the stack. Thus purple, top will be pointing to the purple. And then red is again pushed into the stack. Thus top will be pointing to the red item. At this junction, if we call is full, then we get true, as the available locations are over in this array or stack. thus we'll get stack full. That is true. Now if I pop, we'll get the topmost item, then top will be pointing to the purple. Then again if we pop, then the purple item will come out and top will be pointing to the green. And then if we pop again, green will be coming out, top will be pointing to red. And then again we pop, red will be coming out from the stack and top will be pointing to blue. And then again if we pop, blue will be coming out from the stack and stack becomes empty. In array based realizations, a 1D array will be used and a variable top is used, which is supposed to point to the topmost element in the stack, as shown in the diagram. If we remove or pop an item from this array based stack, the operation looks like this. If you insert, the operation looks like this. As we have already discussed, stack can be realized using linked list also. In these slides, we are showing first time number 2 is maintained in the linked list. So the head of the linked list points to 2. And then when 10 is inserted into the stack, then head now will point to the node having 10. If we insert again another number 7, then head or the top is supposed to point to the node in the linked list having 7. Like this, when we realize stacks using linked list, the linked list nodes will be adding and the respective pointer top will be moving like this. So now currently top is pointing to the node in the linked list having number 7. If we remove that one, top will be pointing to the node having the next number, that is 10. Like this, removal on the stack which is represented in linked list will be carried out. There are many applications which uses the stacks. For example, to find out whether a given string is a palindrome or not, or a given file content, a whole content is a palindrome or not, we may use stack. In summary, we can read character by character till we encounter end of file or till we encounter a null character in the string, then push the character into the stack. Then again we'll go on pop the items from the stack and compare with the first item of the string. Then again pop next item, then compare with the next second item in the second character in the string. If we go on do that, then we can find out whether the string is palindrome or not. This type of applications one can use stack. Let us assume that we wanted to calculate a binary code of a given number. With the help of stack, we can achieve that. See the program segment. We will read a number and then we will continue a loop. As long as that number is greater than 0, we will continue the loop. Calculate number modulus 2 and store it in the variable digit and print that digit and then modify the number is equal to number by 2. You repeat this operation, calculating the number modulus 2 and printing that digit value. If we do, really we are going to get reverse of the given number. Binary code of the given numbers binary code, but in the reverse way it will come. So thus at this junction what we can do is we can take a stack and then we push each digit into the stack, and then once we will come out from that while loop, we go on pop the stack and print the stack content. Then we get the binary code of that number. For example, let us assume that we take the number as 19. First time 19 modulus 2, that is 1, that will be pushed into the stack. Then number becomes 9. Again 9 modulus 2, that is 1, will be pushed into the stack. Then the number becomes 4. 4 modulus 2, 0, that will be pushed into the stack. Then again the number becomes 2. 2 modulus 2, it will be 0, that will be also pushed into the stack. Then number becomes 1. 1 modulus 2, 1, that will be pushed into the stack. And then n value becomes n is equal to number by 2, that is 0. So now we'll come out from the while loop. And if we go on pop it, what we get? 1, that becomes the most significant bit. 0, 0, 1, 1. That is the binary code of the number 19. Like this, with the help of stack, one can get the binary code of a given decimal number. Of course, we can even realize the same thing using recursive functions also. Probably in the previous lectures on recursion, we might have discussed about that. In high-level languages, while evaluating the expressions, we may be requiring postfix expressions to be used. That is, given infix expression, first we may require to convert into postfix, and then that will be evaluated. For this purpose, stacks are used widely, both while converting a infix expression to postfix, and also postfix, from the postfix expression the value evaluation also will be done with the help of the stack. We will be dealing with these conversions in detail in separate chapters. Let us consider the postfix expression is 1, 2, 3 plus star. We are assuming that the operands of the expression are single valued digits, are single digits. So thus we traverse this expression, postfix expression, then operand, first operand 1, it is pushed into the stack. Then again 2, that's also operand, it will be pushed into the stack. 3, again it is pushed into the stack. Now we have got an operator that is plus. Thus we will pop an item. What do we get? 3. That will consider the second operand for plus. Then again we pop another item. We will get 2. That will consider it as first operand for plus. And then we do the operation, that is 2 plus 3. That will be, operation is performed, and that will be pushed into the stack. Thus now stack contains 1, 5. Again next we can take the next character in the expression, that is star. So again what we do? We pop, then we will get 5. That will be taken as the second operand for the star. Then again we will pop 1, we will get, that will be first operand. Thus 1 into 5 is evaluated, that will be pushed into the stack. The stack will be having 5. So now when we verify the expression, there are no more characters in the expression. Just simply we print the value available in the stack. So that will be the value of the postfix expression. Also, stacks are used in verifying whether the expressions are valid in terms of parentheses or not. We will be dealing this problem in detail in the next modules, but however, we wanted to give a feel of it. So we will be traversing the given string or expression character by character. Whenever we encounter a opening bracket, that can be either parenthesis or a square bracket or curly braces, we simply push. Similarly, whenever we encounter a closing parenthesis or a bracket, square brackets or curly braces, we pop the topmost item in the stack. If they are of matching type, the expression is valid till that point, otherwise expression is invalid. If the character what we encountered is not a opening brackets or closing brackets, simply we do nothing with those characters. Like this we will proceed, we will traverse the expression, and after completing the traversing all the characters, if we find that stack is not empty, which means that there are some brackets or parentheses, square brackets or curly braces which are open but they have not yet closed, which means that expression is invalid. So like this, we identify with the help of a stack whether the expression is valid or not. Stacks or stack frames are used in most of the high-level programming languages. Whenever we call a function, a special memory or structure known as stack frame is created in the stack area of the program's address space. The memory required for the arguments, parameters, formal arguments of that function, and also scratch variables, the variables which are used inside that function, they are stored. And also return address is also stored. So that entire data structure is called as the stack frame. The memory required for that is taken from the stack area of that program. Maybe if we call again another function, then one more stack frame is created. Again from that function, if we call again once more, then again another stack frame is created. Of course, here we wanted to remind you one important aspect. Probably you might have faced this problem, especially with recursive functions. So if we happen to call functions recursively, sometimes we may enter into a problem, we may get an error, stack overflow, which indicates that the available stack area of this program is exhausted. Thus, means the entire available stack memory is being spent on creating the stack frames of the recursive functions. There are no more memories left to create another stack frame. Thus, we get a error, stack overflow. In this slide, we are having small code fragment. Two functions are there, f, g. The function f is calling g is calling f. They are employing mutual recursion. So for this type of function call, we may find the stack frame structure as shown above. Another popular problem which one can solve with the help of stacks is towers of Hanoi problem. We have some plates. We are supposed to move these things onto the third stick. However, while moving, one can use a temporary thing, but never the larger one can be placed in the smaller, on the top of the smaller one. Without violating this rule, we are supposed to move. The following slides will demonstrate how stacks can be used. to achieve this one. Stacks are used in some backtracking applications also. That is, some applications in which the operations have to be done at a later stage. They will be pushed into the stack and they will be carried out. The operations will be carried out on them at a later stage. For example, tree traversals, graph traversals, they use this backtracking concept. For this purpose, we use stacks. So when we come to graphs and trees, we will be knowing more about what is this word backtracking. In a nutshell, we can summarize that stack is a data structure in which we can do operations such as insertion, that is pushing, and popping. Both of them will be done at the one end only, the same end. That is known as top end. We cannot insert in between. We cannot remove from in between. Remember, normal arrays, linear arrays, we can do insert anywhere. We can remove an item from, we can access item from middle. Anywhere we can access. Whereas stack, though it is a linear structure, the operations are permitted at one end only. The item which is inserted recently, that is the one is going to be removed first. Thus, they are called as, stacks are called as last in first out queues. The next modules we will be knowing practically how a stack can be realized using an array and how they can be practically used for applications like infix to postfix conversion or evaluating the postfix expression, etc.